Anticipated growth in space mining, biochemistry, and astrobiology sectors by Q4 2026. Overview. The sectors of space mining, biochemistry, and astrobiology are poised for substantial growth, projected at approximately 30% by Q4 2026. This expansion is driven by technological advancements, increasing investments, and a rising global demand for extraterrestrial resources as both governments and private companies explore the potential of space materials. This report delves into the expected developments across these sectors, examining the competitive landscape, investment trends, and expert predictions through 2030. Market overview and growth projections. Space mining market. The global space mining market was valued at approximately $1.64 billion in 2023. Projections indicate a growth rate of 17.6% CAGR, reaching around $5.02 billion by 2030, according to Grand View Research. The business research company anticipates growth from $1.68 billion in 2024 to $4.56 billion by 2029. Reflecting a CAGR of 21.8%. The primary drivers for this growth include resource scarcity. The depletion of terrestrial resources has led to increased interest in space mining as a sustainable solution. Technological advancements. Innovations in space exploration technology have significantly reduced costs and risks associated with mining operations. Sustainability. The global shift towards environmentally sustainable practices enhances interest in space mining as an alternative to conventional mining. Biochemistry and astrobiology. The biochemistry sector is increasingly intersecting with astrobiology, particularly in developing life support systems for space habitats. This sector is expected to benefit from advancements in synthetic biology and bioengineering, potentially facilitating sustainable life in extraterrestrial environments. The integration of these fields is anticipated to contribute to the overall growth trajectory of the space mining sector, as resources extracted from asteroids can be utilized in biotechnological applications. Key technologies and innovations. Technological progress in several areas is transforming the feasibility of space mining. 1. Propulsion systems. Advanced propulsion technology has reduced travel time to asteroids and other celestial bodies, enhancing mission efficiency. 2. Reusable rockets. Companies like SpaceX have pioneered reusable rocket technology, which significantly lowers the costs associated with launching missions into space. 3. Robotics and automation. The development of specialized robotics systems such as the scarcity robot by Asteroid Mining Corporation allows for efficient resource extraction in harsh extraterrestrial environments. These technologies collectively minimize the operational costs and risks, making space mining more viable. Investment trends and competitive landscape. Investment surge. Investment in the space mining sector is witnessing a notable increase, driven primarily by private sector involvement. Companies such as Planetary Resources, Deep Space Industries, and Moon Express are at the forefront of this movement. North America dominates the market, accounting for over 80% of global revenue in 2023, fueled by supportive regulatory frameworks and a robust aerospace engineering sector. The Asia-Pacific region, particularly Japan, is also emerging as a significant player, increasing capital expenditures in space mining initiatives. Competitive landscape. The competitive landscape is rapidly evolving, characterized by the entry of new players and collaborations across the sector. Key players include Planetary Resources, focused on extracting water and precious metals from asteroids. Deep Space Industries, developing spacecraft technology to facilitate cost-effective space mining. Moon Express, pioneering lunar exploration and mining initiatives. As companies innovate and establish strategic partnerships, the competitive dynamics are expected to shift, enhancing market growth. Use cases and resource extraction. Space mining primarily targets C-type and S-type asteroids. C-type asteroids, rich in volatiles such as water and carbon-based compounds. These asteroids are critical for sustaining life in space habitats and can serve as propellant for spacecraft. S-type asteroids, containing valuable metals like nickel, iron, and cobalt. These asteroids are essential for technological applications on Earth and in space. The extraction of these resources not only promises economic benefits but also reduces the environmental impact associated with traditional mining practices. Challenges and market restraints. Despite the optimistic outlook, several challenges persist. 1. High initial costs. Establishing infrastructure for space mining operations requires substantial investment in spacecraft robotics systems and mining equipment. 2. Technical risks. The harsh environments of space pose significant operational risks necessitating advanced technology and expertise. 3. Regulatory hurdles. The legal framework governing space resource extraction remains underdeveloped, which may hinder investment and operational capabilities. Expert predictions and future outlook. Experts predict that the combination of resource scarcity on Earth and increase in space exploration initiatives and advancements in space infrastructure will continue to drive the growth of the space mining industry. The integration of biochemistry and astrobiology into these efforts will further enhance the utility of extracted resources, opening new avenues for research and development. Timeline of key events. 2023, space mining market valued at $1.64 billion. 2024, launch of several space missions focusing on asteroid candidates with the market projected to reach $1.90 billion. 2025, growth anticipated to $2.07 billion fueled by ongoing advancements and investments. 2026, expected 30% growth triggering further investments and strategic initiatives. 2029, market projected to reach $4.56 billion reflecting sustained interest and activity. 2030, long-term projections indicate continued growth with an estimated market size of $5.02 billion. Conclusion. The anticipated growth in the space mining, biochemistry and astrobiology sectors by Q4 2026 is an exciting development driven by technological advancements, increased investments, and the urgent need for sustainable resource solutions. The competitive landscape is evolving rapidly, with key players innovating to capitalize on the vast potential of space resources. As these sectors develop, they will likely play a crucial role in shaping the future of resource extraction and utilization on Earth and beyond. The anticipated growth in the space mining, biochemistry, and astrobiology sectors indicates a transformative shift in how humanity approaches resource acquisition, sustainability, and scientific discovery. Here are some counterintuitive insights drawn from the content. 1. Resource scarcity as a catalyst for space mining. While the idea of space mining might seem futuristic and extravagant, it is actually driven by the pressing scarcity of resources on Earth. This reflects a shift in priorities where extraterrestrial mining is being considered as a sustainable solution to Earth's resource depletion, contradicting the expectation that we would simply increase terrestrial resource extraction. 2. Technological advancements versus initial investment costs. Many may assume that high-tech advancements in space mining would lead to skyrocketing costs. However, the opposite is occurring. Advancements in propulsion systems and robotics are significantly lowering the costs associated with space missions. This points to a paradigm where innovation is making previously unthinkable ventures feasible rather than just increasing expenses. 3. Private sector dominance. Although space exploration has historically been the domain of government agencies, the significant growth of private companies in space mining challenges the conventional notion that only governments can afford and manage such complex operations. The rise of firms like Planetary Resources and Moon Express illustrates a democratization of space resource utilization where private investment is surging against expectations of public sector predominance. 4. Environmental implications of space mining. One might expect space mining to exacerbate environmental issues, however. the narrative has shifted to view it as a potential solution to Earth's ecological crises. By diverting resource extraction away from Earth, space mining could reduce the ecological footprint of traditional mining practices. This is a surprising reversal in the expected environmental impact of such ventures. 5. C-type asteroids as valuable targets. While one might intuitively think that metallic asteroids would be the most sought after due to their metals, the emphasis on C-type asteroids rich in water and carbon compounds is counterintuitive. Their potential to provide essential resources for sustaining life in space habitats and supporting further exploration underlines a strategic focus on life-sustaining resources rather than merely raw materials for technology. 6. Regulatory frameworks as growth enablers. The expectation might be that regulatory frameworks would hinder the rapid growth of new industries like space mining. Yet, in North America, supportive regulations are providing a foundation for the market, facilitating private investments and technological advancements. This indicates a proactive approach to ensure that burgeoning industries can thrive rather than be stifled by bureaucratic processes. 7. Global launch rates and market growth. The significant increase in the number of objects launched into space contradicts the notion that space exploration is declining or stagnating. Instead, it suggests a burgeoning interest in space activities that is expected to fuel demand for asteroid mining and related technologies, defying expectations of a slowing space race. 8. Astrobiology's role in space mining. The interconnection between astrobiology and space mining might not be obvious yet, as technologies for mining advance. The potential for discovering biological materials or life-sustaining resources in space is becoming a critical focus. This could lead to unexpected advancements in both fields, fostering a symbiotic relationship rather than treating them as separate domains. 9. Investment trends and economic diversification. It might seem that space mining would attract only niche investors focused on high-risk, high-reward scenarios. However, the increasing number of stakeholders from various economic backgrounds suggests a broader interest in diversifying portfolios with space-related ventures, which is a surprising development that could reshape investment landscapes. 10. Sustainability over profit. The narrative of space mining has often been framed around potential profits from rare metals. However, the emerging focus on sustainability and the ethical implications of resource acquisition from space might indicate a shift where the motivations for space mining are not purely economic but also driven by a desire to preserve Earth's environment and ensure long-term survival. These insights reveal a complex and evolving landscape for space mining and related sectors, highlighting how societal, technological, and environmental considerations are intertwining in unexpected ways as we move towards a future where space resources may play a pivotal role in human sustainability and advancement. The report on the anticipated growth in the space mining, biochemistry, and astrobiology sectors highlights several key areas that many might overlook, yet they hold significant implications for the future of these industries. Here are the important content points that deserve attention along with explanations of their significance. 1. Technological advancements in robotics and propulsion systems. While the report mentions advancements in propulsion systems and robotics, it is crucial to emphasize the transformative nature of these technologies. For instance, the development of robots like scarcity by the Asteroid Mining Corporation showcases how innovations can enhance both terrestrial and extraterrestrial operations. This technology not only reduces costs but also minimizes risks associated with human involvement in hazardous environments. Significance: the ability to deploy advanced robotics for mining operations can lead to more efficient resource extraction processes, which is essential for making space mining economically viable. It could also pave the way for more ambitious projects such as establishing human habitats on other celestial bodies. 2. Emerging markets and global competition. The report indicates that North America currently dominates the space mining market but hints at the rising interest from Asia-Pacific countries, particularly Japan. The strategic investments in space mining initiatives and the supportive regulatory frameworks in these regions indicate a shift in the global competitive landscape. Significance: this emerging competition could lead to a more diverse set of players in the market, fostering innovation and collaboration. Moreover, it may create opportunities for international partnerships that could accelerate the pace of discoveries and technological advancements. 3. Resource scarcity and sustainability. The report points out that resource scarcity on Earth is driving interest in space mining, but many may overlook the potential environmental benefits of this shift. By accessing resources from asteroids, industries could reduce the ecological impact associated with terrestrial mining, which often involves significant land disruption and pollution. Significance: as global awareness of environmental issues grows, the ability to mitigate ecological damage through space mining could make this industry more appealing to investors and policymakers. Sustainable practices could become a key selling point, attracting investment and public support. 4. Regulatory and legal frameworks. While the report touches on regulatory frameworks in North America, it does not delve deep into the complexities of space law and international agreements that govern resource extraction in space. The Outer Space Treaty of 1967 and its implications for ownership and exploitation of celestial bodies could present challenges for companies looking to operate in this field. Significance: understanding the legal landscape is critical for companies to navigate potential conflicts and ensure compliance with international regulations. Future developments in space law could either facilitate or hinder progress in the space mining sector, making this a key area for stakeholders to monitor. 5. Diverse applications of extracted resources. The report emphasizes the potential of C-type and S-type asteroids for resource extraction, but does not extensively explore the diverse applications of these resources in various industries. For example, water from C-type asteroids could be vital for life support in space missions and serve as fuel, while metals from S-type asteroids could be used in electronics and renewable energy technologies. Significance: highlighting the various applications can attract a broader range of investors and stakeholders interested in specific sectors such as energy, manufacturing, and technology. Understanding the market for these resources can lead to more targeted investment strategies and product development. 6. Investment trends and market dynamics. The report notes increasing private sector interest but does not fully capture the implications of the growing trend of venture capital funding in space-related technologies. The rise of startups in the space mining sector indicates a shift towards innovative approaches and solutions that could disrupt traditional methods. Significance: the influx of venture capital can accelerate technological development and enable smaller companies to compete with larger players. This democratization of the industry could lead to breakthroughs that reshape the market and create new business models. 7. Public and private sector collaboration. While investment trends highlight private sector growth, the potential for collaboration between public agencies like NASA and private companies is an area that deserves more attention. Joint missions and funding opportunities can significantly enhance the capabilities and reach of space mining initiatives. Significance: collaborative efforts can lead to shared resources, reduced costs, and accelerated timelines for exploration and extraction projects. Public-private partnerships could also facilitate knowledge transfer and innovation, making the space mining sector more robust. 8. Geopolitical factors and their impact. The report does not extensively address how geopolitical tensions and global events such as the ongoing Russia-Ukraine conflict could influence the space mining market. Geopolitical instability can affect funding, international collaborations, and regulatory environments. Significance: stakeholders must be aware of how global politics can impact the operational landscape of space mining. Geopolitical considerations could influence investment decisions, the availability of resources, and the strategic positioning of companies in the global market. 9. Implications for astrobiology and biochemistry. The interplay between space mining and sectors like astrobiology and biochemistry is briefly mentioned but warrants deeper exploration. For instance, extracting water and organic compounds from asteroids could have profound implications for understanding the origins of life and developing life support systems for future space missions. Significance: the potential for synergy between these fields could lead to groundbreaking discoveries and innovations that enhance our understanding of life itself and how to sustain it beyond Earth. This integration may also attract interdisciplinary investments and research initiatives. Conclusion: while the report provides a comprehensive overview of the anticipated growth in the space mining, biochemistry, and astrobiology sectors, it is essential to highlight these overlooked aspects to provide a more nuanced understanding of the industry's future. Recognizing the significance of technological advancements, emerging markets, sustainability, legal frameworks, diverse applications, investment dynamics, collaboration opportunities, geopolitical factors, and interdisciplinary implications can better prepare stakeholders for the challenges and opportunities that lie ahead in the evolving landscape of space mining and its associated fields. The anticipated growth in the space mining, biochemistry, and astrobiology sectors by Q4 2026 is noteworthy, with a projected increase of around 30%. Below are the four most valuable points for in-depth analysis and discussion. 1. Market overview and growth projections. The space mining market is emerging as a significant sector, with projections indicating a substantial growth trajectory. Reports suggest that the market, valued at approximately $1.64 billion in 2023, is expected to reach about $5.02 billion by 2030. Marked by different growth rates depending on the source, CAGR of 17.6% per Grand View Research and 21.8% per the Business Research Company. This growth is primarily driven by the increasing resource scarcity on Earth and the technological advancements facilitating space exploration. Discussion points: examine the factors contributing to the projected growth, including technological innovations and global demand for resources. Analyze how the competition in space mining may affect pricing and availability of resources both in space and on Earth. Discuss the potential implications of this growth for international relations and space legislation as nations vie for extraterrestrial resources. 2. Key technologies and innovations. Technological advancements are at the heart of the growth in space mining. Innovations in propulsion systems, reusable rockets, and robotics are significantly lowering the costs and risks associated with space mining operations. For instance, the development of robots like scarcity by Asteroid Mining Corporation showcases the strides being made in robotics for both terrestrial and extraterrestrial applications. Discussion points: explore how advancements in robotics and automation can enhance the efficiency and safety of resource extraction in space. Delve into the implications of reduced costs and increased operational efficiency on the overall feasibility of space mining projects. Assess the ethical considerations surrounding the deployment of advanced technologies in potentially ungoverned spaces. 3. Investment trends and competitive landscape. Increasing investments from the private sector are reshaping the competitive landscape of space mining. Companies such as Planetary Resources, Deep Space Industries, and Moon Express are leading the charge, particularly in North America, which accounted for over 80% of global revenue in 2023. The Asia-Pacific region is also gaining traction, suggesting a shift in the global market dynamics. Discussion points: analyze the role of government policies and regulations in fostering private sector investment in space mining. Discuss the competitive strategies employed by key players and how these strategies might evolve in response to market demands. Evaluate the potential for collaboration versus competition among nations and companies in the burgeoning space mining industry. 4. Challenges and market restraints. Despite the promising outlook for space mining, significant challenges remain. The high initial costs associated with establishing the necessary infrastructure for space mining operations pose a substantial barrier to entry. This includes investments in advanced spacecraft, robotics systems, and specialized mining equipment capable of operating in harsh extraterrestrial environments. Discussion points. Investigate the economic hurdles faced by startups and smaller companies attempting to enter the space mining sector. Discuss the long-term sustainability of space mining operations, particularly in relation to environmental concerns and the impact on extraterrestrial ecosystems. Explore the potential regulatory frameworks needed to address these challenges and ensure responsible exploration and extraction practices. Conclusion. The projected growth in the space mining, biochemistry, and astrobiology sectors presents both opportunities and challenges that warrant detailed analysis. By examining the market dynamics, technological innovations, investment trends, and challenges, stakeholders can better navigate this evolving landscape and make informed decisions about future endeavors in space resource utilization. 1. The Gold Rush 1848 to 1855. The California Gold Rush exemplifies a historical case of resource extraction that dramatically altered economic and social landscapes. Triggered by the discovery of gold at Sutter's Mill in 1848, thousands flocked to California in search of fortune, leading to rapid population growth, the establishment of new towns, and significant advancements in mining technology. This period also highlighted the challenges and consequences of resource extraction, including environmental degradation and the displacement of Native American populations. 2. The Space Race 1957 to 1968. The space race, primarily between the United States and the Soviet Union, marked a significant technological and ideological competition during the Cold War era. It spurred rapid advancements in aerospace technology, culminating in the successful landing of Apollo 11 on the Moon in 1969. The intense focus on space exploration during this period laid the groundwork for modern space missions, contributing to scientific knowledge about asteroids and other celestial bodies, paralleling contemporary interests in space mining. 3. The Industrial Revolution 1760 to 1840. The Industrial Revolution was a transformative period characterized by rapid industrial growth, technological innovation, and resource extraction. The demand for coal and iron fueled mining operations, leading to significant advancements in mining technology and infrastructure. This era not only changed the economic landscape but also had profound social impacts, including urbanization and changes in labor dynamics. The parallels with today's technological advancements in space mining are evident, as both periods involve harnessing resources to drive economic growth and innovation. The anticipated growth of the space mining, biochemistry, and astrobiology sectors is projected to reach approximately 30% by Q4 2026, driven by technological advancements, increased investments, and the rising demand for extraterrestrial resources. As these sectors evolve, they will significantly impact global economic dynamics and competitive landscapes. Market overview and growth projections. The global space mining market was valued at around $1.64 billion in 2023. It is projected to experience substantial growth, with estimates suggesting it could reach $5.02 billion by 2030, representing a compound annual growth rate (CAGR) between 17.6% and 21.8%. This growth is propelled by several factors, including the scarcity of resources on Earth, advancements in space exploration technologies, and a growing focus on sustainable practices. Key technologies and innovations. Technological innovations are at the forefront of enabling space mining activities. Developments in propulsion systems, reusable rocket technology, and advanced robotics have significantly reduced the costs and risks associated with launching and operating missions in space. Notable advancements include the scarcity robot by Asteroid Mining Corporation, which is designed for resource acquisition in both terrestrial and extraterrestrial environments. Investment trends and competitive landscape. Investment in space mining is increasingly dominated by the private sector, with companies like Planetary Resources, Deep Space Industries, and Moon Express leading the way. North America continues to hold over 80% of the global market share, benefiting from a supportive regulatory environment and a robust aerospace engineering sector. Meanwhile, the Asia-Pacific region is emerging as a significant player. with countries like Japan enhancing their capital expenditures in space mining initiatives. Resource extraction and use cases. C-type asteroids, which are rich in water and carbon-based compounds, are expected to be primary targets for mining operations. The extracted water can facilitate life support in space habitats and be converted into propellant. S-type asteroids, known for their metal content, will also play a crucial role in supplying materials for various technological applications. Challenges and market restraints. Despite the optimistic outlook, there are considerable challenges to the growth of the space mining sector. High initial costs for infrastructure development, including the construction of spacecraft and specialized mining equipment, remain significant barriers. Companies must navigate the complexities of operating in harsh extraterrestrial environments, which demands advanced technology and substantial investment. Future outlook and expert predictions. Experts foresee that the combined pressures of resource scarcity on Earth and escalating space exploration efforts will catalyze continued growth in the space mining sector. As technologies advance, new applications for extracted resources will likely emerge in biochemistry and astrobiology, further expanding market potential. Key timeline events. 2023, space mining market valued at $1.64 billion. 2024, key space missions launched focusing on potential asteroid candidates. 2025, market growth expected to reach $2.07 billion, fueled by ongoing technological advancements. 2026, anticipated 30% growth expected to drive further investments and strategic initiatives. 2029, market projected to reach $4.56 billion. 2030, long-term projections suggest continued growth with an estimated market size of $5.02 billion. Conclusion. The outlook for the space mining, biochemistry, and astrobiology sectors is highly positive, with anticipated growth driven by technological advancements, increasing investments, and the critical need for sustainable resource solutions. The competitive landscape is rapidly evolving, with key players innovating and adjusting strategies to capitalize on the vast potential of extraterrestrial resources. As we approach the next decade, the intersection of these sectors will likely redefine resource acquisition and utilization on a global scale.